Hello, welcome, and warm greetings from the team of instructors and myself at the personal tutor virtual classroom. Singularly, I am very happy to have had this opportunity for us to meet for yet another series. My name has been Mr. Samuel Enyuma, and I have been teaching this subject since the year 2011 till date. And have all the competencies that qualifies me to be your instructor. Today, I will be taking the high school phases, and our topic for discussion for this series will be on kinematics. Friends, kinematics belongs to an umbrella topic, a broad topic called mechanics. In order to introduce the lesson, mechanics simply goes this way. In phases, this statement is profound that if a body is at rest, it will continue to be at rest. But that body will only move if an external force is applied to it. In that sense, football placed on the field will continue to be at rest until an external force, until a player kicks it to set it into motion, it will be. So motion is caused by force. Again, a child sitting on a swing will continue to be at rest until pushed by a force to set him or her into the swinging motion. The same goes for a vehicle and other locomotives. They will continue to be at rest until the accelerator is stepped on so that the energy therein is converted to a thrust force to propel the locomotives or the vehicle forward. Simply, motion is caused by force and energy. So to make a body at rest move, force and energy will have to cause the motion. And the branch of science that studies energy and the force that causes motion is called mechanics. And that is the broad topic to be looked at. Mechanics as a topic has got two branches or two arms. One of the arm is dynamics, which in time past was referred to as kinetics. The other arm is kinematics. A brief explanation of the two. The dynamics simply explores that relationship existing between motion and force that caused the motion. Simply, it looks at the relationship between force and motion. How motion is caused by a force. On the other arm, kinematics only concerns itself with the motion of a body, without considering the force that caused the motion. To make it simpler, it only looked at the motion of the body without regarding the force that caused the motion. So these are the two arms of mechanics. But for this series, we're going to look at the second arm called kinematics. And today will be lesson number 1 under the topic kinematics. And as a very good way of commencing the lesson, this will be our learning outcome. That at the end of this lesson, the specific objectives will be that all learners will be able to define at the same time understand the concept of kinematics. We will also look at a definition of motion of a body. Then lastly, types of motion with their related examples. So that is going to be the course outline for today's lesson. So let's commence. Definition of kinematics. As earlier said, kinematics is a branch of mechanics, and it simply deals with the motion of a body without recognition to the applied forces that caused the motion. So it simply studies just the motion to the neglect of the force that caused the motion. You could also say it in a simple term as kinematics studies motion of bodies while ignoring the causes of the motion, that is, the applied energies and forces. Friends, as a concept in kinematics only considers three aspects of a motion of a body. And these aspects are these. 1. The position of the body in motion. 2. The velocity of the body. And 3. The acceleration. Let me provide a simple understanding of these three things. 1. The position simply looks at the location of the body, the distance or the displacement it has covered. That is, if the body was at an initial position and it is set into motion, it changes its location to a final location. The space, the interval between the two locations is the distance. Or better still, where the body was placed initially. Then, if it's set into motion, it is displaced. It changes its motion or its position. And so, position simply looks at distance covered or displacement. The velocity aspect only examines how fast the body is moving and in what direction is it heading on or heading toward. That is the velocity aspect of kinematics. Then, the third concept, the acceleration, only investigate how the velocities of the body is changing. So these are the three aspects of kinematics. In due time, we'll look deeper into each term. Now, let's look at the motion of a body. Since kinematics only concerns itself with motion and not the force that caused the motion. Let's take a look at this picture. It will be two pictures. But for picture 1, there is a body, this time a man, running. He is in motion, whilst his immediate environment is at rest. And by the immediate environment, I mean the trees, the river bodies, the chair you can see, even the road. For the picture number 2, there is another man, but he is not moving. He is stationary. But his immediate environment, and that is the people around him, they are moving. Looking at these two pictures, we want to use that to define what motion is. For the first picture, picture 1, the man, being the body of interest, is changing his position relative to the stationary surrounding within a time frame. So he is moving whilst his environment is stationary. In the second, the body of interest, being the man at rest, still remains at rest relative to the moving surrounding, and that is the people around him, all within another time frame. So by this, you can say that in picture 1, the man is moving because his environment is stationary. Second, the man is at rest while his environment is moving. That is to say that in order to have a very true meaning of motion, there must be a comparison with another reference point which may be at rest or also in motion. That is, we can then define the motion of a body to be the continuous change in position of the body with respect to its surrounding or relative to a reference point at a given interval of time. Okay. In simple terms, motion of a body can also be understood as the dynamic shift in position and direction of a body resulting from the application of forces or energy. So that is the definition of motion. There must always be a reference point for you to be sure that this body is moving or not moving. And a scenario that depicts motion is this: on the field or on a park during athletics, you could see two people or two classes of people. One of the classes of persons may be seated and they are referred to as audience or spectators. Maybe another group of people who are running on a field, and as time elapses, they are changing their position. So, from there, you could say that those who are changing their position within a lapse of time on a field are in motion, relative or respect to those who are seated as audience. Now, comparing those who are changing their position to the audience, you could then say those running are in motion. So the understanding here is that there must always be a reference point for you to define motion of a body. Now, types of motion. If you look all around us, you may see different types of motion, how bodies are moving. The leaves of trees are moving. You could have smoke moving. Vehicles around us are also moving. We are all walking around. Insects are flying over our heads. They're also in motion. There are a lot of things around us. You observe this ball. A, the black ball. B, the blue ball. C, the orange ball. And D, the green ball, to depict different types of motion all around us. So, if you look at the ball A, the ball seems to be on a circular path. The ball B is being translated on a straight course. Ball C, observe it very well, it hits, goes up, hits and goes up. It's kind of bouncing. While ball D, you cannot really tell where it's moving. You can't be precise about its location or its position. It's moving anyhow. So these are few explanations to the various motions around us. Based on this, let's look at some 6 types of motion in physics. And the first type of motion is referred to as rectilinear motion. From the word, there is a clue. You can form another word like linear or even lie, which gives the clue that surely this motion will be on a straight line or in a linear form, as it is depicted by the blue ball here. So any type of motion that is translated this way linearly is rectilinear motion. And the technical definition is it is a type of motion of a body which takes place along a straight line or along a linear So that is the better explanation of rectilinear motion. Let's look around us and look at some examples of motions that are rectilinear. 1. The motion of a bullet fired from a gun. So when a bullet is fired from a gun onto a target, it does not miss because it moves on a straight course to the target. So that is an example of rectilinear motion. 2. Motion of a train on a straight rail or vehicle on a straight road. Friends, trains only goes by the rail. And so if the rail is laid straight, the train will also be straight. And that depicts rectilinear motion. And so our vehicles on a straight road, they will also move straight. The next is the motion of beam of light. So light, as has been said, that when light is translated, it moves on a straight course. The collection of the rays, called the beam of light, moves straight. And in physics, it is termed as the rectilinear propagation of light. 4. The motion of athletes on a 100-meter race on the straight side of the field. So we call these athletes sprinters. They are expected to move straight when they are in a 100-meter race at the straight side of the road or the field. The next example is the motion of an elevator or a lift moving vertically up and down on a shaft. That is another example of rectilinear motion. Then lastly, the motion of a person walking on a straight demarcated line. So these are examples to explain rectilinear motion. Now let's carry on. The next type of motion will be on rotational and circular. But before we look at them separately, I will want to clear the air so that you will understand and not confuse the two. Let's look at these two animations to illustrate what they all mean. Under rotational motion, it simply means the whole body rotates about an axis. Under rotational, the body is rotating on its own axis or about a center of rotation that lies inside the body in motion. What I mean is the points of rotation is on the body moving. In contrast to circular motion, like you have this rotating disc and somebody is seated on it. This red line or this red axle is the axis. That is it. That becomes the center of rotation. Now, this center of rotation falls completely outside the person seated on the rotating disc. So with circular motion, like rotational, they all move on a circular path. But for the circular motion, the point of rotation lies outside the body. So this person could be said to be in circular motion and not rotational motion. The simple understanding that the point of rotation lies outside his body. Let's use this as another example. When you sit on a bicycle, it is the tire that rotates. So you could attest to this fact. But the person sitting on it is not rotating. Therefore, if this bicycle happens to go around a curve or negotiate a roundabout, it is the tire that is in rotational motion, but the occupant on the bicycle is simply in circular motion. I trust you have understood the differences I want to point out here. Therefore, let's take the second type of motion to be circular motion. And as already depicted, this body is rotating although, but the person seated on it, he is not rotating, he is in circular motion. Therefore, you could define circular motion as the motion of a body which takes place along a circular path or along the circumference of a circle about an axis of rotation that lies completely outside the body in motion. And examples around us are when you have children on a rotating merry-go-round. And I will want you to look at this very well. So the merry-go-round, if the children were not seated on it, this merry-go-round will be in rotational motion, with the notion that it is turning around a shaft. The body is rotating on its own axle, and the point of rotation lies on the merry-go-round. But the children who are on the merry-go-round are only in circular motion. They are moving in circles because the point of rotation lies completely outside their body. So that is the best understanding of circular motion, and this example is really very good. The next example of circular motion is the motion of a driver in a car negotiating a curve or a bend. And as earlier said with a bicycle, when a car negotiates a curve, the driver, passengers in it are only in circular motion, but the tire of the car is where the rotation happens, and the point of rotation is on the tire, but the driver and the passengers are completely detached from the rotational point. So that is an example of circular motion. The next example is the revolution of the planet Earth around the sun. And that is when the Earth goes around the stationary sun, it moves in circle. And that is a good example of circular motion. The next example is the orbiting of artificial satellites and the moon around the Earth. Okay, so just as the Earth goes around the sun, artificial satellites as well as the moon also revolve around the sun in orbit. And that is also a good example of circular motion. And the last is the wheeling of a stone tied to a thread. Okay, so with that, when a stone is tied to a thread and wheeled around, the point of rotation is on the human hand, but the stone is only in circles, and that stone is completely detached from the point of rotation. Okay, so that is the understanding of circular motion. Let's now look at rotational motion. And in rotational motion, as earlier illustrated, the body rotates on its own axis. And so the definition is, this is the spinning motion of a body on its own axis, or about an axis of rotation which lies inside the body in motion. So for rotational motion, the point of rotation is completely lying inside. It is part of the body in rotation. And examples will be rotation of the planet Earth on its own axis, initiating day and night. This is this. The Earth rotates. At the same time, it revolves. The revolution is a circular, and it takes 365 days for it to completely revolve around the sun. That is different. But the Earth also rotates on its own axis while revolving. It is this rotation that results in the day and night. So as it rotates, it just takes about 12 hours, then there's a shift over from day to night. So with this understanding, when the earth is rotating, those parts which are facing the sun have day, and those behind have light. And in 12 hours, it rotates back, and those who had day now will have night, and those who originally had night now will have day. So that is the rotation of the earth. The second example is the motion of a merry-go-round. As we said, the merry-go-round on its own rotates. The next is the motion of a wheel rotating on an axle, as it is depicted here. This is a wheel on an axle, also rotate. The next is the motion of a turntable, and this is the turntable, what the DJs use. So if you look at this disc, every part of it is moving. It is rotating because the center of rotation lies inside the body. The next examples, the motion of the propeller of airplane and ship. So the blades, what we call the propellers of both airplanes and ship, also rotate. And lastly, the motion of the connected blades of a ceiling fan are also said to be in rotational motion. As you can really see, that is the ceiling fan. So the next type of motion is the oscillatory motion. With this type of motion, as you can see the animations here, one side of it is faced while the other side swings around. And it is defined as the to and fro motion of a body from its mean position. You could also say the forward and backward motion of a body from a phased point. And a special type of this oscillatory motion is a simple harmonic motion. And looking around us, examples of this type of motion is the swinging motion of a simple pendulum. Now, this animation here is what is referred to as a pendulum. This same pendulum, we have this grandfather's clock, this old giant clock that has some bulb beneath moving tick tock, tick tock. That form of motion depicted is the swinging motion of a simple pendulum. The second type of oscillatory motion is a motion of a car's wiper. If you have ever sat in a car on a rainy day, the driver, in order to wipe the rain from the windscreen, switch on the wipers, and it goes like swish, 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 swish. That kind of motion is also oscillatory motion. The next type is, or the next example is the vibrational motion of a strummed guitar. So when a guitar is struck, it is referred to as being strummed or trammed. As it moves forward or backward or upward and downward, it have this vibrational motion. That also is a good example of oscillatory motion. We also have the motion of a loaded helical spring. Okay, so though it is forward and backward, it could also be upward and downward. And the best understanding is this. This is the helical spring with a load and is set into motion. So this type of motion, down, up, which is also periodic in nature, could be said to be oscillatory motion. The next example is the swinging motion of a seesaw or a swing. Okay, so now you realize that on a seesaw or a swing, what we call the teeter totter for the seesaw, it goes like up, down, up, down, up, down. This type of motion, it's oscillatory. If you look at the swing as well, when someone pushes one on this, it goes that way. This body is also oscillating. So these are perfect good examples of oscillatory motion. And the last example is motion of the clapper of a hanging bell. Okay, so if you go to these Orthodox churches, they have these giant hanging bells. What lies inside that moves ding dong to be hitting the side of the bell is the clapper. So as that clapper moves, it moves with an oscillatory motion. So these are examples of the oscillatory motion. The fifth type of motion is referred to as random motion. And I will want you to just gaze at one of these balls, especially the red balls. Look at how the movement is. So let me select this red ball. Okay. Look at how it's moving. Trying to trace it. Okay. Great. You cannot really follow the path. It has no direction. This type of motion without direction is random motion. So it is defined as the haphazard, irregular, and non-directional form of motion of a body. Random motion is also said to be non-periodic, and they move in any direction with no specific pattern. So that is random motion. And as the name even depicts, random has got an unstable direction. And examples of these random motions are the motion of the molecules of gas, dust, and smoke, as it is animated here. The second example is the meandering motion of flying insects, such as butterfly. If you have ever seen a butterfly before in a garden, when released, you cannot really tell the path the butterfly is taking. It moves randomly and you cannot really trace it in a specific pattern. We also have the random jiggling of water molecules in vigorous boiling. If you have ever noticed water boiling vigorously, that kind of movement, that jiggling movement, is random type of motion. You also have the erratic motion of ants in search for food. So look at these ants. You cannot really trace their path. They move randomly in search for their food. And this is a good example of random motion. The next type is the Brownian motion of particles, such as pollen grains in a liquid. Okay, so you have the pollen grains of flowers placed in a liquid and they are maybe shaked or stirred. They do not really follow a particular pattern. The last example is the motion of boisterous tide and turbulent flow of a liquid. When we say boisterous, that is an unstable, tender-like, heavy tides. The tides, they move anyhow. You cannot really tell their direction. So these are examples of random motion. And the last type of motion is referred to as periodic motion. Now notice the animations here. Look at how it is. The ball kind of have a pattern. Though, yes, you can really tell it is bouncing. Oh, notice it again from the other side. This can be traced. You can see that the interval of bouncing is the same. And let's follow, like it goes like pow, 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 pow. So you can really tell that it is following a regular pattern. So periodic motion is defined as the repetitive motion of a body in a certain interval of time, which is characterized by a regular and predictable pattern of movement. For any motion whose movement could be predicted, which motion could follow a regular pattern and is also repetitive in nature, is periodic. And examples of these are the motion of the ticking of the hand of a wall clock. So notice this wall clock. This is how it ticks. This is how it ticks. So it goes like ke, 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 ke. So these type of motions are periodic in nature. Okay. The next type is the rhythmic beating of the heart of human and other mammals. The rhythmic beating of the heart of humans. So if you have ever placed your hand on your chest, you will easily see that your heart beats in a certain way. Boom, 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 boom. And even if you are frightened, you run and you are a little frightened, you could hear it beat very fast, and it does so at a regular pattern. And that form of beating of the heart could be said to be periodic in nature. The next is the bouncing of a ball at regular interval of time, as you could see being animated here. The next one is the rocking of a cradle. Okay, so you have cradle where babies are kept in for them to be swinging here and there. Okay, like you could easily see, also have one which is meant for play. Okay, so this is the rocking of a cradle. It goes like periodic nature. You could easily say like down, up, down, or forward, backward. These type of motions are also periodic in nature. Okay, so the next example is the repetitive motion of an oscillating helical spring. As we looked at the helical spring under the oscillatory motion, that type of motion is also periodic in nature. And the last is the periodic swinging of the simple pendulum. The pendulum oscillating forward and backward also is an example of periodic motion. Friends and happy learners, this is where we'll end our lesson. Thank you very much for staying with us. And I want to say that the next lesson will be fascinating and very comprehensive. In that, take time and come back to personal tutor. Personal tutor, study at your own pace. It's just an exciting time with you all. See you and stay blessed. Thank you very much.